Welcome to qnawire.
Okay, in this problem, we're going to be finding the total kinetic energy in a mole of gas at 27 degrees Celsius. And then we were asked to find the equivalent speed of a person, about 65 kilometers in mass, running, that would have the same kinetic energy as that mole of gas. So the main equation that we're going to use is the kinetic energy, the average kinetic energy of a particle in a gas at a certain temperature, which is 3 halves times kT. And so all we need to do is multiply this by the number of particles to get the total kinetic energy of the 1 mole of gas. So we could say to get total kinetic energy, we would multiply the average by the number of particles in the gas. And we can actually combine big N with little k to get the gas constant R. So we would be left with 3 halves RT. Let's move over to a new tab. So if we have total kinetic energy of 3 halves RT, where R is the gas constant, and we know the temperature, we need to get it into Kelvin, however. We start plugging things in. We have 3 half times the gas constant is 8.314 joules per moles Kelvin. Okay. However, we've eliminated this. There are no more moles. And we multiply this by 273 degrees, rather 273 Kelvin, plus our 27 degrees of the gas. This is a conversion into Kelvin from Celsius. And if we do this computation, we'll be left with 3740 joules, which is the result for the amount of energy. So for part B, we were asked to find the velocity of a 65 kilogram mass that would be equivalent to this amount of kinetic energy for this gas. So we know the formula for kinetic energy of a mass moving is 1/2 mv squared. So if we're isolating V, we would have V equals the square root of 2k over m. We can plug everything in. Be 2 times 3740 joules over 65 kilograms for this average human. And we would end up with about 11 meters per second. And that's it.